In this lesson, we're going to be learning about right triangle trig. So everything's going to be referenced to a right triangle. So as you're familiar with, this being your right angle, the side opposite your right angle is always your hypotenuse. Now with the two legs, if you notice I've got two statements written beside each one of these legs. One of them's always in reference to angle A, the other one's always in reference to angle B. So depending on which angle you're looking at will determine which of these statements that we're going to refer to. So if I were to go to angle A, this side or this leg of your right triangle would be referred to as the side that's opposite angle A. So we had talked about sides being opposite earlier. So you go opposite angle A, that's what this side is referred to as. Then this side or this leg would be referred to as the side that's adjacent to angle A. So again, from angle A, this would be the opposite side, this would be the adjacent side. So then if you were to look here at angle B, this would be the side opposite angle B, and then going back to angle B to this side, then that would be the side that's adjacent to angle B. So again, from angle B, this would be the opposite side, and from angle B, this would be the adjacent side. And again, this is your hypotenuse. So that's what we're going to be using to define our six trig functions, is based on opposite, adjacent, and hypotenuse. All right, so we're going to start out by first defining sine. And I'm just going to define each of these trig functions just based on angle A, okay? So everything, again, is going to be in reference to angle A. So I'm going to mark that up here on our picture so we won't forget. Sine is always defined as opposite over hypotenuse. So it's just commonly abbreviated O over H. Cosine of angle A, that's going to be adjacent over hypotenuse. So we always just abbreviate it as A over H. Tangent of angle A, that's going to be the opposite over adjacent. So we refer to that as O over A. Of course, if you can remember these three, then you'd have no trouble defining the other three trig functions, because they are just reciprocals of these three. So that would be something you could use to help you memorize this. If you know sine, then you're supposed to know cosecant. So cosecant would be hypotenuse over opposite. Scoot it up here. Secant would be hypotenuse over adjacent. And cotangent would be adjacent over opposite. Now, there is a common little saying that a lot of people use to help them remember this. And it actually only applies to sine, cosine, and tangent. But as I told you all ago, if you can remember those three, then you can easily just remember the other three because of your reciprocal identities. The saying is, Oscar had a heap of apples. So if you were to look at these three, and of course the letter that I use to abbreviate opposite, adjacent, and hypotenuse, with O you would have Oscar had a heap of apples. So that would be your O-H-A-H-O-A. Of course, you have to remember that it goes in the order sine, cosine, tangent. Okay? So just running back through it again real quick. because when I was defining this, I didn't actually use the picture. So if you were asked to find sine of angle A, so you'd have to go to that angle on your picture, and the opposite side for angle A would be here, and of course this is your hypotenuse. So if you knew the length of this side, you knew the length of this side, then you could create that ratio. Then for cosine of angle A, that would be the adjacent side divided by the hypotenuse. And then finally, tangent of angle A, you would go with your opposite side divided by your adjacent side. All right, so now we're going to look at a couple of examples using this information. Okay, so here's the first one. Okay, well, a little bit wider than what'll fit on the screen. The instructions are that you have right triangle ABC, and they're telling you that C is your 90-degree angle. That's going to be your right angle. So the part that you can't see there, I'll scoot it over. It just says to find all 6 of your trig functions of angle A. So it's very important that when you're working these problems that you do pay attention to which angle that they instruct you to look at. So if you want, and most people do better if they have a picture, we're just going to sketch off a right triangle. Doesn't matter what size, just as long as it's a right triangle. Of course, we were instructed that this is C, so I'm just going to let my top angle be A and my bottom angle be B. All right, so I know that side A has a length of 3. So if this is angle A, the side opposite would have to be side A. And I know that side B has a length of square root 7. So if this is angle B, then the side opposite would have to be side B. So there's my square root 7. Now you will need to know your hypotenuse, which you could just use your Pythagorean theorem to locate that information. So A is 3, B is square root 7. So we would have 9 plus 7 is equal to C squared. So 16 is equal to C squared. So that means that C is going to be equal to 4. So there's our missing side. So whichever side it is that you're missing, just use your Pythagorean theorem. All right, so now starting to make the ratios for our 6 trig functions. Okay, so starting out, we'll just start with sine. Now you are asked to do this with reference to angle A. All right, so based on what I told you a while ago, angle A is going to be opposite over hypotenuse. Okay, so of course here is angle A. So from angle A, opposite would be 3, hypotenuse is 4, so that ratio would be 3/4. Cosine of angle A, that's going to be adjacent over hypotenuse. So again, back to angle A, adjacent would be the square root 7. 4 is your hypotenuse again, so square root 7 over 4. Tangent of angle A, so that's opposite over adjacent. Okay, so opposite of angle A is the 3, adjacent is the square root 7. Okay, now I'll scoot over here. So cosecant is hypotenuse over opposite. So that would be 4 over 3. Of course, as we talked about, see, sine and cosecant are reciprocals. So you could check your answer there and just make sure they are reciprocals of each other. And then secant of angle A, so that would be hypotenuse over adjacent. So that would be 4 over square root 7. And finally, cotangent of angle A, that will be adjacent over opposite. So that would be square root 7 over 3. So there are your 6 trig functions of angle A. Again, it's just very important that you do pay attention in the instructions, as to which angle that you're supposed to refer to. Your hypotenuse is your hypotenuse, regardless of which angle you're looking at. It's going to be the opposite and adjacent that you'll get backward if you're not careful. All right, the next problem we have, get this one on the screen for you. There we go. All right, this is very similar to the one we just finished. Of course, this one already has it drawn off for you. You will need to find your hypotenuse. So let's start by doing that. So using your Pythagorean theorem. All right, now technically A, this being angle A this time, the side opposite, so that's going to be 1 squared plus square root 5 squared is equal to C squared. So that would be 1 plus 5. So that would give us 6. So C is going to be square root 6. That's the missing side. Okay, back to your instructions. If you'll notice, these three are all are in reference to angle A. So sine, cosine, tangent of angle A, and then go back and do sine, cosine, tangent of angle B. All right, so we'll start out with angle A. So sine of angle A. So again, that's opposite over hypotenuse. So from angle A, opposite would be 1. Hypotenuse is square root 6. Then cosine of angle A. So that's going to be adjacent over hypotenuse. So adjacent would be the square root 5. Of course, hypotenuse is square root 6. Tangent of angle A. So that's going to be opposite over adjacent. So opposite would be the 1. Adjacent is the square root 5. All right, now we're going to find the same three trig functions, but we're going to do it in reference to angle B. So we'll start out with sine of angle B, so opposite over hypotenuse. Okay, so from B, opposite's going to be square root 5, and of course this is still your hypotenuse, the square root 6. So square root 5 over square root 6. Cosine of angle B, that would be adjacent over hypotenuse. So from angle B, adjacent is 1, and then hypotenuse is square root 6. And then tangent of angle B. So from B, well, that would be opposite over adjacent. Let me write that down. So that would be square root 5 over 1. Of course, that reduces then just to be square root 5. So that would be the completion of that problem.